Welcome to solverfy.
We know that the potential energy of the electron is going to be equal to U sub B. This would be equal to the charge on the electron times the electric potential. This would be equal to negative E times negative 200 volts. And this is equaling 200 electron volts. Now, we can then find its kinetic energy for part A. We can say that the kinetic energy is going to be equal to the potential, rather the total energy, my apologies, minus the potential energy, sub B. This would be equal to 500 electron volts minus 200 electron volts. This is equaling 300 electron volts imparted to the electron. We can say for part B, we're going to use a non-relativistic regime approximation. We can then say that K, the kinetic energy, would be equal to 1/2 mv squared. This would be equal to P squared over 2 times m. And we find the momentum of the electron to be equaling the square root of 2 times the mass times the kinetic energy K. This would be equal to the square root of 2 times the mass, 9.11 times 10 to the negative 31st kilograms, multiplied by the kinetic energy of 300 electron volts. And then for every electron volt, there is 1.6 times 10 to the negative 19th joules. And that is for every electron volt. And so we find that the momentum is going to be equal to 9.35 times 10 to the negative 24th kilograms meters per second. And we find that, rather, this would be the answer for part B. For part C, we're going to find the speed of the electron, v. This would be equal to the square root of 2 times the kinetic energy divided by the mass of the electron. This would be equal to the square root of 2 times 300 electron volts multiplied by 1.6 times 10 to the negative 19th joules per electron volt. We're using that conversion again. And then this would be divided by the mass of the electron, 9.11 times 10 to the negative 31st kilograms. And here we find that the velocity of the electron will be 1.07 times 10 to the 1.03 times 10 to the 7th meters per second. This would be the answer for the speed of the electron. We can find the corresponding de Broglie wavelength. Wavelength would be equal to the Planck's constant divided by the momentum. This is going to be 6.626 times 10 to the negative 34th joules second. And then this would be divided by the momentum of 9.35 times 10 to the negative 24th kilograms meters per second. This is going to be equal to 7.08 times 10 to the negative 11th meters. This would be the corresponding de Broglie, my apologies, de Broglie wavelength. For part E, we're trying to find the angular wave number. This would be simply 2 pi over the wavelength that we had found in part D. And so this would be 2 pi divided by 7.08 times 10 to the negative 11th meters. And we find that the wave number is going to be 8.87 times 10 to the 10th. And then this would be per meter. That is our final answer. That is the end of the solution. Thank you.